Assalamualaikum warahmatullahi wabarakatuh. Welcome to the Electrical Circuit Laboratory. Let's introduce ourselves. My name is Bilan Friska Aina with assistant code is BFA.
Hello everyone, my name is Rio Anantas Tepu with assistant code RES.
Hello everyone, I'm Muhammad Raihan Baswara with assistant code ERB.
In this video, we will explain the practical step in the first module. That is introduction and application of LTSpice. Well, let's just watch this video. To take part in all electronic circuit laboratory practicum, you must install LTSpice application. If you have opened the application, then a screen will appear like this. So we click on New Schematic, which is in the upper left corner. In the first module, we only need voltage and resistor. On the toolbar above, here already display passive component such as resistor, capacitor, inductor, and diode. While we also need this voltage, so we just click this component. This component have been sorted alphabetically from A to Z. While the initial letter voltage is V and includes the last letter, so we just slide into the right. Or we can also type here according to what we are looking for. Well, just press OK, then click the left mouse and it's done. Click the right mouse. For the resistor, we just click on the toolbar in the circuit in the first module voltage sources in the left. Then the resistor to be connected rotate 3 times, while if the voltage sources on the right is allowed to rotate is 1 time. Well, we also need a resistor here in a vertical position. Don't forget to each circuit in LTSpice must be connected to ground in order to run. Well, if it's all, then we connect it with wire and we can click into the toolbar. To set the value of the component, we can right click and appear like this. So this applies to all components. Okay, the circuit is finished. Then the next will be explained by Rio.
Okay, next. When finished with the circuit component that have been given, we continue with the simulation by clicking Run. And then asking for the edit simulation command. In this simulation command, we use the transient analysis. And this transient is how we simulated the circuit to graph, where on the horizontal side is the time and on the vertical is a quantity that we will measure later. We put the stop time, the domain, let's say 1 millisecond. Then press OK, and then the Spice LT window will be divided into two, namely the upper window where this position will be filed by the graph that will be displayed, and in the lower window is the circuit. In this video, we will measure voltage, current, and power. In the first, we will measure the voltage simple by moving the cursor on the component, such that we want to measure, for example, two components on R1, and then we point the cursor until red, which indicates the probe is positive. And then we slide and hold this probe until it's turned white. Then paste it on the resistor on the side so that it's turned black, means negative. And after releasing the cursor simulation, we appear in the top window that display amount of voltage in R1 is 5 volts, or we can click on the label and then see the magnitude of the voltage is 5 volt. Thank you.
Okay, thanks Rio. So, on this occasion, I, ERB, will explain about how to measure current and resistance using a simple circuit in Module 1. For the analysis, we use transient analysis with a stop time of 1 millisecond. Okay, let's just run. To measure the current, we left-click on the component we want to find the value for. So for example, I want to measure the current on R1. I just left-click in here. Then the graph will show the value. I left-click here. Then, as you can see, here the current value is 1 ampere. Next, we will measure resistance. To measure resistance, we use Ohm's law, which is where V equals I times R. To find resistance, we must first measure the voltage and current. So I delete this trace. And then we run again. To measure the resistance, we have to measure the amount of voltage and current first. Now, we first find the magnitude of the voltage. Because the equivalent R that we measure is R1 and R2, then we will measure the voltage at the ends of the components. So we measure starting from here. Left click, don't forget to drag the cursor to the end of the R2 components in here. Then as you can see, a graph will appear along with the value of the magnitude of the voltage of 10 volts. Next, we look for the current magnitude as described earlier. We simply left-click on the component we want to find. For example, I want to find the current in R2. I left-click, then a graph will appear along with the magnitude of the current value of 1 ampere. After that, to measure the equivalent resistance, with the help of this voltage graph at V node 001, previously we first copy the formula in the flow editor expression. Here we copy. Then to the voltage editor expression. Enter the slash or division symbol formula. Then we paste the formula in the flow editor expression that was copied earlier. Paste. Then press OK. Then a graph of the equivalent resistance will appear. You can see here the result is 10 ohm. I delete this trace first to make it clear. I run again. So you can see that here the result of the resistance equivalent is 10 ohm. Okay, so maybe that's more likely the practicum steps in Module 1. Enjoy watching and understanding. You can do it on the journal. Last but not least, RL forever. Thank you.